Hello and welcome friends. In this particular presentation, we'll be discussing about the construction of the Vernier Theodolite and basic definitions that are related with Theodolite surveying. Broadly, the content is will be getting introduced with the Theodolite operations, construction of Vernier Theodolite, Vernier scale, basic definitions and temporary adjustments related with Theodolite. As you learn the content, you will be able to recognize the parts of the Theodolite and their respective functions. You will be able to explain the basic terminologies used in Theodolite survey, as well as you will be able to set the Theodolite on the station and carry out the temporary adjustment, which is basic step in Theodolite surveying. Whenever we are dealing with any compass or say level like equipment, usually we define the line of sight in the horizontal plane. Hence, the objects which are in the immediate vicinity of the equipment lie below the line of sight or lie above the line of sight cannot be sighted. As such, the survey will not be complete or otherwise it may take considerable time. Hence, we are making use of Theodolite-like equipment in which the way you see. With respect to that, say, horizontal line or horizontal plane, the telescope can be rotated about the horizontal axis and hence we can sight the objects below or above the line of sight. Similarly, the telescope can be rotated about its vertical axis in the horizontal plane and hence we can measure the angles. As such, Theodolite does have the ability to measure all the basic measurements, that is horizontal distance, vertical distance, horizontal angle, vertical angle. As such, any surveying operation can be facilitated by making use of this particular Theodolite like equipment. Measurement of the horizontal distance and vertical distance by Theodolite needs some small changes and accordingly the method is indirect one. As we proceed further, you will come to know how that particular Theodolite can be transformed into tachometer and how one can make use of that particular transformed Theodolite in order to measure the distances. Mainly, this equipment is very useful for measurement of the horizontal and vertical angle, for the location of the points, for prolonging survey lines, for leveling operations, for setting out the grades, for ranging the curves. Here, this list is not limited to what is mentioned here. According to the surveying requirement, Theodolite can be used for any operation which is the basic, say, requirement of any surveyor. Theodolite can be classified as transit and non-transit. That is, whenever we are thinking about this particular telescope of the equipment, this earlier equipment, this particular telescope used to be quite long and hence this particular telescope cannot be rotated about its say horizontal axis in the vertical plane and such equipment were termed as non-transit, whereas the equipment in which nowadays mostly the telescopes are internal focusing type, their lens could hardly be say 15 centimeter to 17 centimeter and accordingly this particular telescope can be rotated in this particular say vertical plane about its say horizontal axis. the equipment is termed as transit. Today, non-transit is almost obsolete. All theodolite that we use are of transit category only. Theodolite can also be treated as vernier theodolite, micrometer theodolite, digital theodolite. Here, the vernier theodolite is mechanical theodolite. It is provided with the verniers in order to measure the angle in horizontal plane as well as vertical plane, and hence it is called as vernier theodolite. Whereas micrometer theodolite are optical equipment. They have certain optical arrangement in order to measure the angles. It is also equipped with the micrometers in order to enhance the reading to lesser extent. As such, these particular equipment, micro-optic or micrometer theodolite, are more precise as compared to vernier theodolite. Usually, micrometer theodolite are of 1 second theodolite. That is, they have the capability to measure up to 1 second of angle. The modern theodolite is of digital category. They are very easy and their digital display can be used in order to have these particular readings. Usually, all these particular kind of the theodolite are expressed in relation with the diameter of that particular graduated circle, usually which is 8 centimeter to 12 centimeter. Whereas, as this particular diameter of this particular graduated circle is high to the tune of around 14 centimeter to 25 centimeter, the equipment are more precise and are usually used for triangulation purpose. So, great triangulation, great accuracy is achieved with larger theodolites as they have this particular bigger graduated circles. Here, though theodolite could be micro-optic, digital, and some small deviation with respect to each other, most of the discussion that we'll be having will be related with this particular first category, vernier theodolite only, and the basics that we discuss related with this particular vernier theodolite are mostly applicable for all the versions of the theodolite that are available over the world. So here what you see is micro-optic theodolite. The central one is vernier theodolite, whereas this is the modern theodolite, which is nothing but the digital theodolite. This is sectional elevation of vernier theodolite, and their various pairs are shown in this particular numbered manner. As we move further, you will understand what are that various pairs. So let's try to discuss about this particular theodolite construction and the parts. Leveling head is the lowermost part. Already the relevant discussion about leveling and level is much clear to you. That's why most of the parts that are related to this particular equipment could you hear as a repetitive type. Here, this leveling head comprises of tri-branch plate, trivet plate, which is separated by 3 leveling screws. As you know, this leveling head helps to level the equipment. Now, the function of tri-branch, trivet and leveling screw is very similar to the way we discussed about level. Here, as we move ahead, what you see is 2 spindles. One is solid category, other one is some hollow category, which are fitted within each other with the same vertical axis. The upper portion that you see is called as upper plate, and the lower portion that you see is termed as lower plate. this upper plate and this particular say spindle is termed as inner spindle or inner axis, whereas this particular lower plate is said to be outer axis of that particular equipment. Here, this upper plate is provided with vernier A and vernier B, which are placed opposite to each other in order to facilitate the smaller fraction of the main divisions. This is also called as vernier plate. The lower plate that you see is related with main scale. It provides the graduations of 0 to 360 degrees. Here, let's get acquainted with two screws. The way you see here is there is a provision of upper clamp as well as there is a provision of lower clamp. So, whenever this particular upper clamp screw is tightened, both plates can rotate together. Whereas, whenever the lower clamp screw is tightened and upper clamp screw is loosened, only upper plate is movable about the vertical axis. When both the plates are clamped, the instrument cannot move in the horizontal plane. The next part that you see in the form of this particular say vertical bars is nothing but a frame or standard. The standards are the frame which supports the telescope and allow it to rotate about the vertical axis. Generally, they are in A shape. That's why it is called as A frame. The clipping arm of the index frame and the arm of this vertical circle clamps are also attached to this particular A frame. As we move ahead, you will understand what is meaning of this particular clipping arm of the index frame and P frame. Usually, a true compass is attached with this particular A frame in order to measure bearing of a line. This particular trip compass is detachable type. There is provision of vertical circle clamp arm. It is integral part as far as this particular vernier frame is concerned. This vernier frame is also called as T frame, or it is also called as index arm. So here, this particular frame comprises of two arms. One is horizontal, another one is vertical. The way you see here, that horizontal portion is called as index arm, as it is provided with vernier C and vernier D to facilitate the portion of angles rate in the vertical plane. Whereas this particular low arm is called as clipping arm. It is provided with clip screw. In turn, this particular clipping screw is provided with some fork. It is provided with certain spring loaded plunger, so that whenever we wish to have certain permanent adjustment related with the equipment, it can be used. Under normal circumstances, one is not expected to touch as far as this particular clip screw is concerned. Vertical circle is fitted to the telescope and it rotates as telescope rotates. It has graduation in each quadrant at 0 to 9 degrees. The line horizontal whenever we consider the horizontal line, it will be having graduations of 0, 0, whereas the uppermost point and the lowermost point will be having graduation of 90 degrees. There is a provision of the altitude bubble tube in order to ensure the horizontality of the telescope. So whenever we wish to measure the vertical angle, the index must be leveled before taking each readings. This particular vertical circle can be clamped by making use of vertical circle clamp. The vertical circle is provided with the clamp and tangent screws as in the case of horizontal plane. Upon clamping the vertical circle, the telescope cannot be moved in a vertical plane. The tangent screw allows for slow and small motion of that particular vertical circle. This particular clamp and their respective tangent screws are very helpful in order to have the small, slower motions of the telescope in horizontal as well as vertical plane. The telescope is focusing part which has the object lens as well as eyepiece at its other ends. Here, the way you have used the telescope for leveling equipment, very similar manner, this particular equipment is provided with that particular telescope. Here, it has the capability to rotate about the horizontal axis, which is called as Vernier axis, in the vertical plane. Only the thing is that it has got better aperture and magnification as compared to double level like equipment. The upper plate is provided with this particular horizontal level tube. There could be two plate level tubes placed perpendicular to each other, or otherwise there could be simply one plate level which is essentially used for leveling of the equipment. The way we discussed about the vertical clamp, here the equipment is provided with the upper clamp as well as lower clamp. So here we have already discussed about the inner axis related with this particular inner spindle, outer axis which is related with this particular hollow spindle. So here whenever we are making use of this particular say lower clamp, whenever we are making use of upper clamp, so there could be certain small deviations as far as say constructional aspects are concerned, but here there is a provision of upper clamp, there is a provision of lower clamp, there is a provision of upper tangential, there is a provision of lower tangential, and the way we discussed earlier, we can make use of these screws simultaneously in order to facilitate the reading operations. The whole assembly of this particular theodolite is resting on the tripod through the leveling head. So here there is a provision of threaded housings in the trifect which can be used in order to have this particular assembly of theodolite fitted over the head of the tripod. So tripod is nothing but the stand on which the theodolite is mounted. It should be placed in such a way that theodolite would occupy the exact level position. It is provided with the legs as well as the metallic shoes at their ends in order to have the telescope fitted properly over the ground. Tripod has a certain external screw which helps to attach the theodolite by tri-branch plate in the fixed position. In addition, even there is a shifting arrangement which we will discuss in subsequent slide. The Vernier scales provided in the Theodolite is one of the essential spare for measurement of angles with better precision. It is supplementary scale which slides along the main scale, could be related with the horizontal main scale as well as even the vertical scale. There is a provision of two verniers for the horizontal scale as well as vertical scale in order to enhance the measurement capability of the equipment. So here you can see the graduations. You can see here that particular T frame which is helping us in order to define that particular vernier C and vernier D as far as vertical angle measurement is concerned, vernier A and vernier B as far as horizontal angle measurement is concerned. As one uses the equipment, one should understand how the least count of that particular equipment can be determined. Let's try to understand this particular feature in detail. The way I presented on earlier slide, these are certain graduation patterns. The upper graduations are related with the vernier, which are marked in minutes and 20 seconds, whereas the main scale is provided with degrees and minutes. So here each degree, the way you see, is divided into 3 parts. As such, each division reads here 20 minutes. Let's try to understand how we can make use of the scales in order to determine the least count of vernier scale. For horizontal angle measurement, the main circle is graduated from 0 to 360 degrees in clockwise direction. The way we discussed here, each main scale division represents 20 minutes. For the vernier, 59 main scale divisions are divided into 60 parts. Hence, 59 main scale divisions form 59 into 20 minutes. Therefore, each vernier scale division represents 59 into 20 by 60 minutes. The amount a vernier division differs from a division of the main scale determines the smallest reading of the scale that can be made with the particular vernier. The smallest reading is nothing but the least count of that particular vernier. As such, least count of the vernier can be presented as main scale division minus vernier scale division. Hence, the way we discussed here, main scale division is 20 minutes, whereas vernier scale division is 59 into 20 minutes divided by 60. As such, what we get is nothing but 1/3 minute. As we convert it into seconds, the least count appears to be 20 seconds, which is applicable for this particular case. Also, it can be determined by dividing the value of the smallest division on the main scale by the number of divisions on the vernier. The smallest division of the main scale is 20 minutes, whereas as we see here, there are 20 main parts. Each part is divided into 3 divisions. As such, there are 60 divisions on Vernier scale. Hence, 20 by 60, which comes to be 20 seconds. There could be variety of theodolite which may be having different scale graduations as well as Vernier divisions. If we follow this particular procedure, we'll be able to determine least count of each of the equipment. The way you see here, least count could be even 1 second for some theodolite. For routine theodolite, it could be 20 seconds, but it could also be 1 minute, 30 seconds, 20 seconds, 10 seconds. The graduation patterns, the way you see here, could be like this. So the value of the smallest division on the main scale divided by the number of the divisions on the Vernier, the way we use accordingly here, the least count can be determined 1 minute. In the similar manner, here the least count can be determined as 20 seconds here. The vertical circle is main part which helps us to measure the vertical angle with respect to horizontal plane. So the way we discussed earlier, the horizontal is presented as 0, 0, whereas the uppermost point is graduated with 90 degrees, lowermost point is also provided with that 90 degrees, and accordingly we can measure the angle the way we sight the object in elevated manner or in depression manner. So here the vertical circle is graduated as 0 degrees in the zenith also. What I mean to say is this 90 degrees could be graduated as 0 degrees, and with respect to that particular vertical topmost direction, one can measure the angle. Here, the diametrically opposite placed verniers are used in order to have the angle read with 20-second precision. We have already discussed about the index arm of the T-frame, which helps us to measure the angles. While taking the readings, care must be taken to read the vernier in the direction that applies to the angle observed. Here we are discussing about the vertical angle measurement. So the way you see, the vernier is placed with the graduations. The one is increasing in order, whereas the other one is provided with the reverse order. So here it is 0 to 15. Here the way you see is say 5 to 20. So here this particular 0 and this particular 0 as provided could be creating confusion when one is not accustomed with the graduation patterns. That's why one has to be particular about using the set of the graduations on this particular Vernier scale, which are increasing in the same order the way the graduations on main scale. So if there is an angle of elevation, the graduations will be increasing in order. So one has to refer this particular say lower scale. Whereas if there is certain say angle of depression, so at that time the graduations which are decreasing in the order of that particular graduations should be referred. Whenever we are doing this particular theodolite surveying, we very often use these particular terms, that is centering of the equipment. In leveling operation, the centering of the equipment was not required because you were mostly related with taking the readings in the form of back side, intermediate side and foresight on this stuff. Even if we alter the position of the equipment, the reduced level calculation won't change with the equipment position. It is not so as far as theodolite is concerned. Here, we set the equipment with respect to a particular station, and maybe horizontal angle or vertical angle should be read with respect to that particular station only. Hence, we have to center the equipment. So it means setting the equipment exactly over that particular peg, so that one will be having the vertical axis of the equipment passing through that particular peg, giving the position of the station under consideration. For theodolite, one can make use of plumb bob which is attached through the special housing provided through that particular privet. One can make use of also optical plummet in order to sight the position of the station as far as constructional aspects are concerned. Usually, whenever one is interested in centering the equipment exactly over the station under consideration, one makes use of these particular tripod legs. Next, one makes use of the plumb bob. Thirdly, one makes use of optical plummet. So, all such operations will help us to center the equipment exactly over that particular station. In addition, if we consider the theodolite, it is provided with certain specific arrangement which is called as shifting head arrangement. So for the telescope, as we consider the upper plate, on that plate there is one small circular plate which is attached with the spindle, which can be moved through certain 1 centimeter margin. It can be clamped with the leveling head, or it can be loosened with the leveling head by making use of clamping arrangement. So as that clamping arrangement is loosened, we can shift the equipment bodily over the leveling head through that particular 1 centimeter margin, the way the surveyor is interested. As such, refined centering can be facilitated by making use of this shifting head arrangement. In addition, in order to sight the objects in the forward direction as well as in the backward direction, we can rotate the telescope in the vertical plane. So the way you see here, now the telescope is sighting for the object which is in the forward manner. It can be rotated fully through 180 degrees, and accordingly it can be just turned in the opposite direction to sight the object in the reverse manner, in the backward order, without altering the position of the lens. As such, the rotation of this particular telescope in the vertical plane is termed as transiting, or it can also be termed as plunging, or it can also be termed as reversing operation. we have the object sighted, through the proper arrangement of that particular upper clamp, lower clamp, we can have this particular say vertical circle kept on the left side of the observer. So here this particular yellow rectangle represents the vertical circle. So here it is on the left side of the observer. This is the eyepiece of that telescope. This is object end. Hence, this condition is termed as face left condition. Similarly, here by keeping both the screws, upper clamp and lower clamp, in the looser manner, we can have the rotation of this particular telescope fully in the horizontal plane so that it will be having the direction in the same manner, but the vertical circle will be kept on this particular right side of the observer. This position is termed as face right position. Whereas the operation that we do in order to have this particular telescope keeping at the requisite direction and having the vertical circle brought on the left side or right side is termed as changing the face. Leveling is associated with making the axis of plate level horizontal. This operation is very similar to the leveling aspects that we discussed for level. Also, the line of collimation and the axis of telescope is having the same terminology that we discussed previously. Here, every theodolite is provided with set of fundamental axes, which are termed as vertical axis, horizontal axis, line of collimation, axis of altitude level tube, axis of plate level. So, here the way you see, this is the vertical axis of the equipment about which the telescope rotated in horizontal plane. This is horizontal axis, which is nothing but also called as Vernier axis, which is passing through the bearings provided at the top of that A-frame about which telescope rotates in the vertical plane is nothing but horizontal axis. Line of collimation, which is nothing but the line of sight, which is defined by the intersection of the vertical hair and horizontal hair of the diaphragm and the optical center of that particular object class. Whenever we have the altitude level tube leveled, the bubble will be at its crown point. At that time, the horizontal line, which would be tangential to that particular position of the bubble, would be termed as altitude level axis. This is associated with the vertical angle measurement. Whereas in general, whenever we use equipment for its leveling aspect, we make use of plate level, which is nothing but the axis related with the position of the bubble resting at its middle of the run, that is at the crown point, with the longitudinal level tube provided over the main skull. So here this particular axis have to bear certain relationship when the equipment is in perfect adjustment. The vertical crosshair should lie in a plane perpendicular to the horizontal axis. The axis of each plate level should lie in a plane perpendicular to the vertical axis. The horizontal axis should be perpendicular to the vertical axis. The axis of the telescope level should be parallel to the line of sight. The line of sight should be perpendicular to the horizontal axis at its intersection with the vertical axis. Also, the optical axis, the axis of telescope and the line of sight should be coinciding each other. One of the important operations is setting up theodolite. So here this particular sketch gives the idea how the equipment can be set. It is from Leica manual. So we'll be following specific steps. We'll be setting up the tripod with its head approximately horizontal above the station. So how this is set? It goes with the skill of the surveyor. The attempt should be made to have these particular legs making inclination of 60 degrees with the horizontal. Also, depending on the height of the surveyor, it is expected to have this particular tripod set at some convenient height. Then, the way you see here, it has got certain, say, threaded housing. So we keep the equipment on that particular head and we make use of that particular clamping screw in order to fix the equipment on this particular head. As we do so, it's better to have all the leveling screws which are separating the tri-branch and trivet brought at middle of their run. Then we make use of these particular legs. We move them radially, we move them circumferentially so as to have the leveling and centering done by making use of, say, plumb bob attached at the trivet. One thing one should note as far as Theodolite is concerned, we have to have the equipment leveled as well as centered, and this has to be done simultaneously. As one tries to level the equipment, centering will be disturbed. As one tries to center the equipment, leveling would be disturbed. Hence, both the operations should be done hand in hand, simultaneously, yet very accurately in order to produce the correct results. So, this leveling is done by making use of bubble tube and set up leveling screws. As you know the process, that is, we'll be keeping that proper telescope parallel to any two port screws. We'll be bringing the bubble at center of the run. We'll be making the telescope 90 degrees to that particular position. Again, we'll be making use of the remaining screw and so. So here you know that it's a leveling aspect. Here, as we have the leveling done, mostly the last step is associated with using the shifting head in order to slide it exactly above the station. As we make use of shifting head, usually there is not much change as far as leveling is concerned, but if at all there is small, one can have the leveling done by making use of leveling screws. So, as the exact centering is done by making use of shifting head, equipment can be fixed. The next thing is adjusting the Theodolite. So adjustments are built into this particular, say, permanent adjustment. As we discussed on the previous slide, equipment has got vertical axis, horizontal axis, axis of altitude level tube, axis of plate level tube. We have to have certain relationship among that particular axis, and we wish to maintain that particular axial relationship. And in order to do so, what we do is nothing but permanent adjustment. Whereas for each of the station setup, we wish to have certain axial relationship maintained for that particular equipment setup only, and the kind of adjustment that we make for that equipment setup are nothing but the temporary adjustment. So centering, leveling, focusing of the eyepiece and the object glass are temporary adjustment. Once again, I would like to recall. Centering, already we discussed about. Leveling, you know how to level by making use of leveling screws, as well as removing the parallax. Already we have discussed in detail as far as the presentation related with leveling is concerned. Just to have the processes recalled, one may please go through the content that I have presented here. This particular equipment is always a preferred option for the surveyor. Presently, nowadays, the digital version of the Theodolite is available, as well as even the total station equipment is available, but it needs certain expertise to how the things regarding handling, data recording, data producing, data manipulation, and as such. Theodolite is sturdy equipment, but one must attend various sources of errors. As you know, there could be instrumental errors, there could be personal errors, there could be natural errors. So, if the various pairs that we discussed are not properly maintained, say for example, if the plate bubble tube is not in, say, perfect adjustment, if the line of collimation is not perpendicular to that particular horizontal axis, if the horizontal axis is not being produced perpendicular to the vertical axis, so there could be certain loose parts, or there could be certain, say, mishandling associated, because of which there could be certain, say, eccentricity of inner and outer axis. The graduations may not be, say, properly done. Verniers could be eccentric. So all these things can be brought under instrumental errors. Because of one's mishandling, as well as if one is not conversant, say particular example, I would like to again take up that particular clip screw. Even in certain textbook, I have read that clip screw can be used for leveling. No, it cannot be used for leveling. It has to be used for permanent adjustment of that particular equipment. So because of such, say, negligence associated with the one's knowledge, there could be many personal errors. So one should avoid that. One should think about even the aspect associated with the altitude level tube. Altitude level tube is more sensitive as compared to that plate level tube. So while taking that particular, say, vertical angle, one must facilitate that particular leveling operation, taking into account the sensitivity of that particular level tube. So if one does not know about that, there are always chances of the involvement of such personal errors. As well as there could be temperature variation which causes this particular, say, irregular refraction. There could be high winds which could be causing the vibration of the equipment. There could be, say, brightness which may not be facilitating the exact pass sections. Hence, one must be very particular as far as the choosing a particular time slot in order to enhance the accuracy in works. As far as vernier theodolite is concerned, one must have enough expertise. Firstly, to work out the least count of the equipment, and secondly, to read the vernier divisions exactly in order to present it to the capability of the equipment. As we move ahead, as we deal with the angle measurement aspects, the idea will be more clear. One more thing, theodolite, as far as its construction is concerned, there are many spares. I could have missed some of that particular construction aspects, but as we move ahead, I'll be retouching certain parts, because of which the concept of handling of that particular theodolite will be very clear to you. So thanks for your attention. In the next presentation, I will discuss about the horizontal angle measurement in theodolite survey. So bye till then. I wish you very happy learning. Thank you.